All right, this will be a short little video for section 1.1 in Big Ideas Math. This one will talk about solving simple equations. So there are a couple key ideas we really need to think about this section. And when they put this into words, they say adding the same number to each side of an equation produces an equivalent equation. So if we look at the equation they have down here, well, A is equal to B. So if we said 5 is equal to 5, and we add some number C to both sides, whether that's 3 or whatever, we get 8 is equal to 8, which is still a true statement. So what we do to one side, we have to do to the other, especially when it comes to addition. What you'll find is the subtraction property of equality says the exact same thing for subtraction. So if we have A is equal to B and we subtract C from both sides, we have an equivalent equation. So likewise, if I had 5 is equal to 5, and instead of adding 3, I'm going to subtract 3, I'm going to get 2 is equal to 2, which is still an equivalent equation. So we're going to be able to manipulate equations using this to help solve for different variables. And remember, our variables are our letters in these equations. Okay? So in letter A here, we have solve x minus 7 equals negative 6. Well, if this is a negative 7, I need to get this to 0. So what I'm going to do is I'm going to add 7 to both sides. Okay? So I have x left on my left side. Well, negative 6 plus 7 gives me a positive 1. So I'm trying to get this to equal 0 in this case because x plus 0 is still just x, or 1 plus 0 is still just 1. That's why we're trying to get to that number. So x is equal to 1 for the first one. In letter B here, we have 1 equals w plus 6. Well, in this case, we have a positive 6 here. So in order to get that to 0, we're going to have to subtract 6 from both sides. Well, I get left with w on the right side. Well, 1 minus 6, this gives me a negative 5. And that's our answer for letter B. In letter C, we have a y here. So y plus 3.4 equals 0.5. So we want to get this to y equals. So in order to do that, we are going to subtract 3.4 from both sides. We do that because this is positive, and I want to get this to 0 again so I can cancel it out just like that. I have y equals 0 plus a negative 3.4 would give me a negative 2.9. Okay. There are some extra questions for you to try on your own. If you want to try them at home and bring them to me, we can go over them together, but I will leave those open for you. Okay. Some extra key ideas here. We have the multiplication property of equality, which is going to state the exact same thing as our addition and subtraction equalities. If we do it to one side, we have to do it to the other. So if we multiply by a number, on one side, we multiply by that same number on the other side to keep this two sides equal. And likewise with division, you will see the same thing. The only caveat is C can't equal 0. But you should not be put in a position where you'll have to worry about that, okay? So in this case, we're going to start out tough right away. So I always look at fractions as both multiplication and division, because we could rewrite and say, hey, I got negative 3. All right, we're going to write this down as negative 3 over 4 times n equals negative 2. Well, now I'm dividing by 4 here. Well, to undo division, I'm going to do multiplication. So I'm going to multiply both sides by 4, because 4 over 1 would mean I can cancel this out. So then I have negative 3 times n equals negative 8. Okay? Well, now I have a negative 3 times n. Well, now, if it's multiplication, I need to undo that with division. I'm going to divide on both sides. And I get n is equal to 8 over 3, because our two negatives are going to cancel out, and we're going to have a positive answer. All right. This one will be a little bit easier. We need to solve pi times x equals 3 times pi. Well, pi is what we want to get rid of over here so we can have just x. Well, in order to undo multiplication, we have to divide both sides by pi. On the left, pi cancels there, and all we get left with is x. On the right, pi cancels again, and we have x is equal to 3. One's much easier, right? So when I go back up here, I would strongly advise doing one piece of these fractions and then doing the other. So you undo the division by multiplication, which is what we did here. And we undo the multiplication by division, which is what we did here. Okay? Try it yourself for a couple times, see what you can come up with. This number 5 might be wrote a little bit better because you'll see to multiply that 3 looks a little bit easier. In example 3, we want to identify the solution of an equation. So what value of k makes the equation k plus 4 divided by 0.2 equals 5 true? Well, by our order of operations, we have to make sure, I'm honestly going to simplify this first because I think that's going to be the easier way to go about it. So we're going to take k plus, now our order of operations says we have to do parentheses, then exponents, then multiplication and division all before addition and subtraction. So we're going to divide this out first. So I'm going to pull this up, and I'm going to take 4 divided by 0.2 and get 20. So k plus 20 equals 5. Now I shouldn't need that again. So I subtract 20 from both sides because I have addition here, so I need to undo that with subtraction. So if I subtract 20 on both sides, I'm going to have k equals 5 minus 20 gives me a negative 15. And so then I look and I find negative 15 is A. And that question is solved. Got a couple more for you to check. When you check your solution, what you end up doing is taking this negative 15 and plugging that back in for k. So I'm going to rewrite all of this with negative 15 substituted in for k. So we do the same thing. We have to do this piece first because of our order of operations. So we have negative 15 plus 4 divided by 0.2 gives us 20 equals 5. Well, negative 15 plus 20 is 5. 5 equals 5, and we are correct. That is how we check our answer. Okay? There's a self-assessment section. This would be really good for you to all go over on your own. But we'll talk about the modeling in real life. And the temperature in a crater on Mars is 0 degrees Celsius at 1 p.m. The temperature decreases by 8 degrees Celsius every hour. When will the temperature be negative 50 degrees Celsius? So they start by saying to determine when the temperature will be negative 50 degrees Celsius, find how long it will take for the temperature to decrease by 50 degrees Celsius. Write and solve an equation to find the time. So I'm starting at 0 degrees Celsius, and for every hour x, we are going to lose 8 degrees. Okay? Okay. So we start at 0 degrees Celsius. For every hour x, we're dropping 8 degrees Celsius. Okay? Well, if it's 2 hours, it's going to be 16 degrees. It's going to be 24 at 3 hours. So if I start at 0, I'm going to have to subtract off because I'm losing my temperature. Well, for every hour, I lose 8 degrees. And I want to find out when this equals negative 50. Okay? Well, 0 minus 8x, this is just negative 8x equals negative 50. And now we divide by negative 8 on both sides. And we say x is equal to 50 divided by 8 gives us 6¼ hours, or 6.25 hours. And that is how we find that one out. Once again, please let me know if you have any questions. There's a lot of self-assessment stuff in here for you to work on, and I hope I will have a good problem set for you to go through as well. But please let me know if you have any questions. That was section 1.1, solving simple equations. Thank you.